Ever noticed how many things just run on autopilot these days? Traffic lights, those factory lines you see in documentaries, even those automatic doors at the supermarket. It's wild.
Yeah.
Turns out,
Yeah.
a lot of that everyday automation we take for granted, it all comes down to these little devices called PLCs.
Right.
They're like the tiny computers you don't see that keep our world running smoothly.
Absolutely.
So today we're taking a deep dive into the world of PLCs.
Yeah.
From their beginnings to where they might be headed.
It's a fascinating history, really.
It totally is. Full of twists and turns.
A lot of adaptation and evolution in the story of the PLC.
Speaking of adaptation,
Yeah.
you know what's interesting to me? Henry Ford, Mr. Assembly Line himself, he might have actually missed a big lesson when it came to adapting with technology.
Oh. Hold on. Are you saying the assembly line genius himself, Henry Ford, missed out on something crucial for success? Tell me more.
So Ford, he was all about mass production, right? Revolutionized car manufacturing with his assembly lines.
Oh, yeah.
Churning out Model Ts faster than anyone thought possible.
Efficient.
But he's also famous for saying, any customer can have a car painted any color that he wants, so long as it is black.
The old Ford quote.
Talk about inflexible.
And, that's where his competitor, Alfred Sloan and General Motors, that's where they saw an opening. Sloan, he understood that they crave variety, they want a choice.
Right.
GM, they started offering a whole rainbow of car models, colors, features.
So while Ford was busy making every car identical,
Yeah.
GM was busy adapting to what people actually wanted.
Exactly. And that flexibility in how they built their cars, it gave them a huge advantage. And, well, it helped them win over a lot of customers.
So how does this all relate to PLCs? I mean, we're talking about cars, factories,
Right. It feels like a bit of a leap.
but it feels like there's a connection here.
Oh, there absolutely is. See, before PLCs came along, factories relied on these massive systems of relays to control their machinery. Imagine, walls of clunky metal boxes,
So,
each one controlling a single action and all connected by this jumble of wires.
sounds like a nightmare waiting to happen.
It really was. These relays were slow, they wore out all the time, and they generated so much heat it was unbelievable.
Really?
Oh, yeah. Just imagine the troubleshooting nightmares. Trying to find a single faulty wire in that mess.
I can only imagine.
It would drive you crazy. And don't even get me started on rewiring those things to adapt to new processes. It was a gargantuan task.
Yeah, I was just thinking, it had to have been a pain.
Oh, it was. Like trying to rebuild your entire house just to change a light bulb, honestly. So you can
Wow.
see why people were desperate for a more adaptable solution.
Yeah, that makes a lot of sense.
And that, my friend, is where the PLC comes in.
So the PLC was born out of necessity then, kind of like how GM swooped in when Ford's methods were too rigid.
Precisely. It was the late 1960s, and this company called Bedford Associates, they later became Modicon. By the way, they were working on this project for General Motors
Okay,
to try and bring some sanity to this whole electrical chaos.
I bet.
And they came up with a revolutionary idea. What if, instead of physical relays, you could create virtual ones using computer memory?
Wow, so they were essentially miniaturizing and digitizing this whole system.
Yeah.
Making it adaptable in ways those old relays never could be.
Exactly. It was a stroke of genius, really, that would completely change industrial automation forever.
So instead of this tangled mess of wires and sparks and giant boxes, you got this neat little PLC with software calling the shots.
Yeah. It's like creating a whole toolbox for one of those fancy Swiss Army knives.
Right. But I have to imagine, for the engineers back then, it must have been a learning curve.
Oh, definitely.
I mean, they were used to working with physical relays, not computer code. So how do they even
Right.
bridge that gap?
Well, that's where the real ingenuity of the PLC comes in, I think. They didn't just invent the technology. They made it, well, user-friendly.
Make it make sense.
Exactly. They developed this special programming language just for PLCs, and they called it ladder logic.
Ladder logic. Okay, it rings a bell, but
Yeah.
remind me.
So imagine visual coding, but instead of dragging and dropping blocks of code around,
Okay.
you're using symbols that look a lot like those old electrical diagrams, Those ladder-like schematics with all the lines and symbols for the circuits.
Ah, so it's like they were speaking the engineer's language. We know you love your diagrams, so here's a programming language that feels familiar.
Exactly. It was genius, really. It made it so much easier for those engineers to transition from those old relay-based systems to this new world of programmable controllers.
So PLCs were born out of necessity, but it sounds like their real genius was in how approachable they became. They took this cutting-edge tech and made it make sense, which is probably why they took off the way they did.
Yeah, and just like we saw computers linking up to share information, PLCs started doing the same thing, becoming even more powerful by working together.
Right.
And as technology advanced, they got smaller, they got faster, and they could handle more and more complex tasks.
So they weren't just controlling individual machines anymore. It was like they were orchestrating entire systems.
That's a great way to put it.
Mm-hmm.
And with that increased connectivity, suddenly we had all this data.
Oh, yeah.
We weren't just controlling things anymore. We were gathering all this information about how those processes were actually working.
Mm.
And that's a pretty significant turning point, I think, in the story of the PLC and where they might be headed in the future.
Okay, so this is what I think is really interesting. What happens when the very thing that made PLCs possible computers starts to become competition?
That is the million-dollar question these days, isn't it? We're seeing this rise of computer-based data acquisition, DAQ they call it for short, and it has the potential to, well, shake things up a bit.
So instead of just telling a machine what to do, DAQ is more about gathering all that data, kind of like a detective on the factory floor. Tell me more about that.
Yeah, exactly. It's like they're the Sherlock Holmes of the industrial world, these DAQ systems.
Okay, I like it.
They can track so many things at once, thousands of variables, all in real time.
Wow.
Analyze trends, even predict problems before they happen.
So it's like having a crystal ball for your factory.
Exactly.
That's incredible.
Yeah.
It seems like we're on the verge of this whole other level of automation and control now.
We are. And here's the thing. While PLCs are amazing at following instructions and providing that reliable control, they weren't really designed for this level of in-depth data analysis. That's where those DAQ systems come in. They offer this whole new level of insight and potential optimization that could really revolutionize things.
So what does that mean for the good old PLC? Are they going to go the way of the dinosaur, become obsolete like those clunky old relays we talked about?
Sure.
Or will they adapt?
That is the big question.
So are PLCs going the way of the dinosaur? They've been around so long, been such a workhorse.
Right.
It's kind of hard to imagine factories without them.
It's definitely a turning point, that's for sure. Some experts think, for certain applications at least, where you really need that deep data analysis and that next level adaptability, that traditional PLCs, they might get phased out, replaced by those more versatile computer-based systems.
A changing of the guard.
Yeah.
But PLCs, though, they've always been favored for being, well, simple, rugged,
Yeah.
and factory floors.
Right. Not exactly the most forgiving environment.
Exactly. Not known for being friendly to sensitive electronics or anything.
And that's why, I really do think PLCs are going to remain essential, especially in situations where you absolutely need that robustness, that real-time control. They've proven themselves, right?
Right.
Decades they've been around in tough environments. They just work.
They just work. Maybe we'll see them adapt, incorporate some of those fancier data analysis tricks, get even smarter, even more efficient.
Yeah, like a fusion of the old reliable with the new cutting edge.
Exactly.
That's a great way to put it.
So not an either or, but a both and kind of situation.
I think that's the most likely scenario, honestly. We might see more of a hybrid approach where you've got PLCs handling those really important real-time control tasks.
Okay.
And then you've got those networked computer systems taking care of the data analysis, the optimization, all that.
A real tag team effort. PLCs holding down the fort, keeping things running smoothly, and then the DAQ systems. They're providing that high-level strategy.
Exactly. Working together. And that kind of teamwork, that synergy, that could lead to some seriously impressive automation systems in the future.
Wow. What a journey this has been, honestly. We started with Legos, talking about Model Ts.
Right. Oh, no.
And here we are talking about the future of factories, cities, all thanks to these little boxes of, computing power.
It just shows you the need for efficiency, for flexibility.
Yeah, and now data, right?
Yeah, data analysis is huge now. It all drives how technology changes and evolves.
And it always comes back to adaptation, doesn't it? Being able to roll with the punches, evolve, that's crucial. Car companies, control systems, even those old relays.
It's a constant evolution.
Absolutely. So next time you see one of those perfectly timed traffic lights or you're watching a documentary, you see a factory running like clockwork.
Yeah.
Take a second to appreciate the PLC behind the scenes. It's a testament to how powerful adaptation is and a little glimpse into how technology never sits still.
And keep an eye out for those new technologies, the ones that might just spark the next revolution. Who knows what's next?
That's right. Possibilities are endless. This has been a fascinating deep dive. Thank you so much for joining us. And until next time, keep those minds curious.